Rule number 2, dividing powers. Okay, here's an example. You have x to the power of 3 divided by x to the power of 2. Now x to the power of 3 is x times x times x, and x to the power of 2 is x times x. So what I'm going to do is I'm going to cancel the x divided by x, right? So x divided by x is 1, so that's what we're doing. We're just turning it into a 1 or canceling it. And x divided by x here is 1. Okay, so these become 1s, and so we have 1 times x, which is just x. Then we want you to notice that x is the same as x to the power of 1. And you should notice that x to the 3 divided by x to the 2 is the same as x to the 3 minus 2, which is 1. Okay, here's another example. Here's x to the power of 6 divided by x to the power of 4. And I'm going to rewrite the x to the 6 as x times x times x times x times x times x, and x to the power of 4 as x times x times x times x. All right, then we're going to start canceling them off. Okay, so those are all 1s. Okay, so we have 1 times 1 times 1 times 1, which is 1, times x times x. Now x times x is x squared. Okay, so we're left with x squared. So notice that x to the 6 divided by x to the 4 is the same as x to the 6 minus 4, which is x to the 2. Here's another example. X to the 9 divided by x to the 7. All right, here we have 9x's multiplying each other divided by 7x's multiplying each other. So what I'm going to do is I'm going to cancel off x divided by x is 1. And then x divided by x is 1. And so we're going to end up with 7 1s multiplying each other. And we're going to be left with 2 x's that are multiplying each other. Okay, so these 7 1s multiplying each other is 1. Okay, 1 times 1 is 1 times 1 is 1. Okay, so we have 1 times x, which is once again x squared. Okay, so we end up with x times x, which is x squared. And notice that x to the 9 divided by x to the 7 is the same as x to the 9 minus 7. Okay, now this is where it gets a little bit different. Here we have x to the power of 2 over x to the power of 4. Okay, which is x times x divided by x times x times x times x. Once again, we're going to cancel. Okay, so I'm going to cancel these 2 x's and those 2 x's. All right, and when we do, we get a 1. So I'm left with a 1 on top and x times x on the bottom. Okay, and x times x is x squared. So we're left with 1 over x squared. Okay, now the shortcut for this is once again we're going to subtract. But the trick is, the catch is, you're always going to subtract the smaller exponent from the larger exponent and put the answer where the larger exponent was. Okay, notice we have x to the 4, which is a larger power than x to the 2. The larger exponent is 4. It's larger than 2, which means we have more x's on the bottom than we have on the top, and after you finish canceling, you're going to end up with x's on the bottom. Okay, so we end up with 1 over x to the power of 2. Okay, so notice that x to the 2 divided by x to the 4 is the same as 1 over x to the 4 minus 2. Biggest exponent, subtract the smallest exponent, and put the answer where the biggest exponent was. And that's really all there is to it. Here's another example. X to the 4 divided by x to the 9. Okay, once again, that's 4 x's on the top, multiplying each other, divided by 9 x's on the bottom, multiplying each other, and then I'm going to just cancel like this. So x divided by x is 1, so I'm going to end up with 4 1s multiplying each other, which is going to leave us with a 1 on the top, and we end up with 5 x's on the bottom. Okay, so we end up with 1 over x to the power of 5. And notice that x to the power of 4 divided by x to the power of 9 is the same as 1 over x to the 9 minus 4. Once again, the larger exponent subtracts the smaller exponent, and the answer goes to where the larger exponent was. And the reason for that is because you have more x's where the larger exponent is, okay, or more y's, or whatever your base happens to be. Okay, so rule number 2 is when you have x to the n divided by x to the m, subtract the exponent, put your answer to where the largest exponent was. Okay, so if the larger one's on the top, just leave your answer on the top. Okay, so if n in this case is bigger than m. So if the larger exponent was on the top, you leave your answer on the top. So here's example 1. X to the 20 divided by x to the 12 is going to be x to the 20 take away 12, which is x to the 8. Okay, example 2. 3 to the 19 divided by 3 to the 16, subtract the exponents, 19 take away 16, put the answer on the top, 3 to the power of 3. Okay, which is 27. Okay, example number 3. Here we have 2 to the 9 times x to the 11 times y to the 7 divided by 2 to the 3, x to the 8, y to the 4. And we're going to subtract the exponents. So the bigger minus the smaller, 9 minus 3, is going to be 2 to the power of 6. X to the 11 minus 8. Well, we're about to run out of time. Stay tuned for part 2. All right, here's part 2 of rule number 2. So we're looking at example 3. We have 2 to the 9 times x to the 11 times y to the 7 divided by 2 to the power of 3, x to the power of 8, y to the power of 4. So what we're going to do is we have division of powers. When we have that, we subtract the exponents. Always subtract always subtract the smaller from the larger. Put the answer where the largest power was. Okay, so we have 2 to the 9 divided by 2 to the 3, so it's 2 to the 9 minus 3. Okay, just like that. And 11 is bigger than 8, so the answer goes to where the 11 is, which is on the top in the numerator. So we have x to the 11 take away 8. And here the 7 is bigger than the 4, so we're going to get y to the 7 take away 4. Okay, which is going to give us 2 to the 6, 11 take away 8 is 3, and 7 take away 4 is 3. So we have 2 to the 6, x to the 3 times y to the 3. And that's it for example 3. And let's move on to example 4. Okay. Now, this is the same rule, believe it or not. All right, so we have x to the m divided by x to the n, and what we're going to be doing is, in this case, I'm saying that n is bigger than n, okay, like that. And so what we do is we subtract the m from the n. Okay, this will prevent us from getting a negative exponent. Okay, so what you do is you subtract the exponents and always put the answer where the larger exponent was. Okay, now you remember why that is. Okay, if we go back to our example 5, for example, we have x to the power of 4 divided by x to the power of 9. You have 4x's multiplying each other on top, and you have 9x's multiplying each other on the bottom. Okay, you're going to cancel 4 of those x's, right, from the top and the bottom. And so you're going to end up with more x's on the bottom, 5x's on the bottom. Okay, so that's why you always put the answer where the largest power is. Okay, provided that you have the same base. All right, so here is example 4. We have x to the 7 divided by x to the 11. Now the 11 is bigger than the 7, so the answer is going to go at the bottom. And we're going to have 1 over x to the 11 take away 7, which is 1 over x to the 4. It's as simple as that. Here's example 5. We have 3 to the power of 12 divided by 3 to the power of 20. And the answer is larger on the bottom. The exponent is larger on the bottom, so the answer goes to the bottom. And it's going to be 3 to the 20 take away 12, which is 1 over 3 to the power of 8. Example 6, we have 2 to the 3, x to the 4, y to the 9 divided by 2 to the 7 times x to the 12 times y to the 5. Now this is a bit of a mixed bag because on the bottom we have a larger power with the 2's. With the x's, we have the larger exponent on the bottom. With the y's, however, notice we have the larger exponent on the top. Okay, so we're just going to put the answer where the larger exponent is in each case. Okay, for the 2's, the answer is going to go to the bottom. So we're going to have 2 to the 7 minus 3 on the bottom. For the x's, the answer is going to go to the bottom, so it's going to be x to the 12 minus 4. For the y's, the answer is going to go to the top. It's going to be y to the 9 minus 5. Okay, which is going to give us y to the power of 4 divided by 2 to the power of 4, x to the power of 8. All right, and that's it for example number 6, and that's it for rule number 2. Have a good day.